Hi all, this is Harini. Welcome back to the YouTube channel Code with Harini. Today we are going to solve LeetCode Day 27 challenge, which is count health and values in an array. So they'll be giving us an integer array nums. So at index I will be a part of the L if the closest non-equal integers of I are smaller than nums of I. For example, this is the I 4. So the closest integers is 2 and 1. Okay, if both are smaller, then this is a hill. Okay, you can take it into account. Similarly, an index I is a part of the value if the closest non-equal neighbors of I are larger than I. So let's take num here 1. Okay, if you see 4 and 6 are greater, this is smaller, right? So which means this is a value. Adjacent indices I and j are same part of hill or valley if nums of I equals to nums of j. So here if you take this 4 will be one hill and this 6 this 1 together will be one value. You can't take this one separately and this one separately. So that's what they have stated. Note that for index to be part of the hill or valley, it must have a non-equal neighbor on both the left and right of the index. So we can't take 2 in consideration to and 2 and 5 in consideration to any of the hill or valley because it doesn't have the two closest neighbors. Okay, that's at end. So we have to return the number of the hills and valleys in nums. Okay. Now for this example, if you see uh, at 0 there is no non-equal integer of 2 on the left. Okay. The same at 5 there is no non-equal integer on the right. So we won't take into an account. Now we'll go to 4. 4 on the left, I minus 1 is lesser than 4, I plus 1 is greater than, lesser than 4. So this is a hill. So we'll take into account 1. So next, these both are equal. So this will contribute to the same hill or valley, right? So then before one is greater, after one is also greater, so it contributes to the value. Next 5 comes. 5, yeah, as we discussed, there is nothing on the right, so it will not contribute to anything. Okay, I forgot to say 6 on the left, it also less, on the right also less, so this will also contribute to hill. So we have 2 hill, 1 valley, so in total the answer is 3. So here that is 6 6 5 5 4. So if for 6 we can't take anything, 1 also we can't take because this is the ending and starting. So if you take 5, these 5 on left it is greater, on the right it is lesser, so it won't contribute to any value. 4 if you take on the left it is greater, on the right it is smaller. So either they both should be greater or smaller, then only it can contribute to the hill or valley. So here the answer is 0. Now just take a look at the visual representation and how we are going to solve this particular question. Let's take this nums as an example. Okay, first thing what we should consider. Okay, if you're taking, we should ignore the last. Okay, water. So here if you see we have 3 1 at the last, so we have to ignore this 3 because on the right because these contributes to the same value, right? On the left it doesn't have anything, on the right only it has. So the same here. On the right it doesn't have anything, only on the left it has some value. So for to consider to hill or value, on the left it should have some non equal neighbor, right? Yeah. So now if you see 4 comes, on the left it is less, on the right it is greater. So this also can't take. Less, greater, this also we can't take. So less, this is greater. 6 comes, this is greater and this is lesser. For 4, this is greater and this is lesser. So for 3, this is greater and this is less. So either both should be less or greater, na? So here it comes. So this is greater and this is also greater. Okay, so our ants count will get incremented to 1. See, 1 is greater than 1, 4 is greater than 1. Okay. Now when 4 comes, 1 is lesser and 3 is also lesser. So, okay, now the count got incremented to 2. So now we have to, after seeing this index, whatever the previous equal, if it is equal in neighbors, so we should count together, right? Okay, now for 4, we will be like, we'll keep on counting this and we'll be checking, okay, where is this starting? So that starting is greater than or less. Present in this index or this index. Okay, if we are present at this index, you have to do I plus how many same equal neighbors were there. Okay, I plus what are, let's assume that variable as a temp. I plus temp is greater or lesser, we have to count. Okay, if this is greater, this is also should be greater. So what our condition would be, either I plus temp, okay, should be lesser than nums of I, should be nums of I should be greater than nums of I minus 1 if you are going forward. Okay, but forward you don't know how many same element exist. So, but if you are coming till here, previous how many previous are equal, if nums of I equals to nums of I plus 1 or I minus 1, if you keep on counting that, you will at this index, you know, okay, we know that two elements are equal, so temp power count will be 2. So counting and coming to the last index is easier than keep on checking the forward index. Both we can do, but yeah, that is more easier and convenient at one loop. So now nums of I minus temp. So my assumption is now I'm at this index. So my I minus temp is less than nums of I greater than nums of I minus 1, or this should be greater to have a hill. Now if the nums of I is greater, then it is just hill. If nums of I is smaller, that is a value. This is the condition, right, that we are going to use. To count nums as a value, how will you count temp? If at any index, if nums of I equals to nums of I plus 1, okay, from this particular position, I'll be keep on checking I plus 1 is equal, I plus 1 is equal. Here I plus 1 won't be equal. So what our temp will be? Temp will be 3 to 1. So to the max, only one can be there will be possibility only one non-equal values exist. Okay. So what we will be doing will not when you are counting whether it's a hill or value, you have to reset to the 1 if it is not equal, if it doesn't fall into both the cases. Like here, greater, say one value is lesser and another value is greater also, you should go into just resetting the temp value to 1, unless if it is same, we won't do less or equals to 1. These are the different scenarios that we'll be using to solve this and adding it to the count. Now just we have discussed, have written in the form of code to solve this. So if you just see, so first we have to check whether these are same to add it to the temp to get to what is our previous neighbor, what is our next neighbor, right? So that we'll be doing once we have, okay, there is no equal value, then we know, okay, our I minus temp will be checking whether it is a hill or value. If it is so, you will be adding and resetting the count. If not, that is not hill or valley, then we'll be just resetting the temp to 1. Then we'll be returning our count. So as we know that we won't take into consideration first and the last. Okay, now just run through the example that we have used. Okay, now I will be 1 and I will be 1 and temp will be 1. So nums of I equal to plus 1. So temp will get updated to 2. Now I will get updated to 3. 3 and I plus 1 is equal? No, right? So what it will do? It will not taken 10 plus 1, it will not get taken into account. And nums of 3 minus 2 will go to I is now 3 minus 2 will go to 1 is greater. These all same values, right? Is greater than nums of I? No. And nums of I minus temp is not is lesser than nums of I. But it will check nums of I plus 1 also is lesser than 4. No, it is greater and this is lesser. So this doesn't form neither hill or valley. Now the temp will get again reset to 1. Okay, now I comes 4. Nums of I equals to 5. 5 minus temp is 4, right? 5 minus 1 is 4 is greater. No, it is lesser. Then this also should be lesser. No, but it's not the case. So it will not do anything. The temp will same updated to temp will be again 1. So now it will go to I equal is 6 and the corresponding value is 7. So 7 is not equal to 8. What it will happen now, it will check, okay, 7, the nums of I minus temp which is 5. 5 is lesser than nums of 5. 5 is lesser than 7, but it's not lesser than 8. So what it will happen, it will just reset the value to the next, it will go to just next pointer. It won't do anything because it neither form a hill nor. So I go 7, 8 comes. So 8 is not equal to 6. So not same hill or valley. So but it is I minus temp is 7 less than 8 and greater than 6, so it forms a hill, right? Now this condition satisfies. Now again we have to reset to temp because it's not something temp, we are just using to store the count of the same. Okay, now we are resetting and our count got updated to 1. On 6 you see 6 plus 1 is not same, so it will go here. So here it has value 8 which is greater and 4 which is lesser, so it won't form any hill or value. So again temp got reset to 1. Now we'll be going to the next index 4. 4 will check with the next index is 3. I plus 1 and 4 is not equal. Now if 4 comes to the LF condition, 4 is greater and lesser than 6, so it forms greater less. So this also won't go into neither hill or valley. So the temp will get just updated to 1 and our now it will go to the next index. 3 comes. Now that our temp is okay, nums of I equal to I plus 1. Now the temp will get updated to 2. Now and again when I goes here, I plus 1 and this was not equal. So what it will do, it will come here. Now it will check our current I is Now our current I is 10. Okay, now our I came here. So as we discussed here, now if you see I minus 10 minus 2 was 8. So nums of 8 is 4 and the current nums of I is 3 and nums of I plus 1 is 1. Okay. So if you see here, this is greater, this is lesser. So it won't form any hill or value. Now again the temp will get reset to just 1 only. 1. Now I will go to 11. If you see, I will go here and here. So temp will get updated to 2 again. And 2 minus I will be 12. So 12 minus 2 is 3. And I plus 1 is 4. And now it is, so these are, it is also greater and this is also greater. So it forms a value. So the account will get updated to 2 and temp will get resetted to 1. Okay. Now I goes to 13, the value will be 4. For this 4, I plus 1 is not equal, so temp will not get incremented, so it will come here, number of I equals to 4. And I minus temp is 1, I plus 1 is 3. So this is lesser than this. This is also lesser, so it forms a hill. So again update the count and we will uh, update the temp to 1. So now the count got incremented to the last integer we won't check, right, because we are traversing thread and length of nums minus 1. We won't check because there is no element on the right. So yeah, I hope this makes sense why how the hill and values are getting counted. Basically we are not doing anything. We are just, if it is same, add it to the temp. Have a temp variable. If it's not, okay, then we have previous non-equal neighbor, next non-equal neighbor. But if it is both are less, it will contribute to the hill. The current is hill because it is both are less. If not, the current is valley and the both are so like this. So now I am less. So now I am forming valley if both are greater. So now I am on top. If it both are valley, now I am hill. So which is less. So yeah, these are the conditions that we are checking and we are resetting to the temp once we finish checking and count. If not any of them was not there, then we are just updating the temp to 1 and we are returning the count and the count was 3. So what basically the time complexity and space complexity, time complexity is order of n. We are just traversing. And the space complexity is order of n. We are not storing anything other apart from the temp and count. That's all a variable, so that won't contribute to anything. I hope this makes sense. Yeah, if you have any questions, please do leave a feedback. I will answer. And if you didn't understand anything or if you need further more clarification, please let me know. I'll explain that part better in upcoming videos. Yep. Thanks for watching.